This video continues to explore the AsyncTask, a tool provided by Android to perform short-term processing in the background. This is part 2 in a 4-part series on AsyncTask. The objectives are stated here with a timeline for when they appear in the video. This is a preview of a longer video. Visit ProfessorAndroid.com for more information. Alright, so let's take a review of where we're at so far. We have an activity called main activity. And in the button click event, it creates a new task. This data type here, task that extends AsyncTask. When it creates one, it sends in the this pointer of the activity that's creating it. And in this constructor, we receive that this pointer and store it in a reference called host, the activity that's hosting this async task. We then say task.execute, which starts the life cycle of the async task and sends in two string parameters, task1 and task2. When that occurs, it starts by invoking onPre-execute, which is a method that is thread safe for our UI thread in our activity, and we can talk to views in our activity inside this method. It then starts processing in a doInBackground method, which performs processing on a separate thread, and we are not allowed to talk to our activity through this doInBackground that's a separate thread of execution. We are, however, allowed to call publishProgress, which invokes onProgressUpdate, which is a method that can be called over and over again from doInBackground to update some views to show progress on our activity that holds the reference to this async task. After this doInBackground method has completely run, it does have a return parameter that we have not dealt with yet that we will in this video. It then calls onPostExecute. The only other method that could be invoked is onCanceled if we chose to give the user a way to cancel the async task before it's completed. Alright, so let's move on from there and take a look at this return parameter that we haven't looked at yet. And you can really use that return parameter for anything you desire or not at all. So had we come in here and used the parameter void here when we created this async task, we would have had a void here. We wouldn't have had a return statement here because it wouldn't have returned anything. And then we wouldn't have passed anything into onPostExecute because that's where the return value comes into play to post it back to our activity so that it can use that return value. In our particular case, I just put a long in here as a placeholder basically, so I used 3 different data types when I originally created this async task. I'm just going to go ahead and change that now to an integer just so we can see that correlation. If this is an integer, that means this has to be an integer, and that means that this has to be an integer. And all of that was stubbed out for us originally when we created the async task. So if we want to change that data type, we've got to change that in all 3 places. I'm going to keep this simple in terms of how many tasks did we do. In other words, if we passed in 2 things here, I want to return back the fact that we processed 2 items. So our return value will be the number of items that we processed for this example. But that could be a bitmap image. It could be some type of a record set from a database query. It can be any object type that you want to return. For this example, all I need to do is to come in here and say params.length, and now I am going to return the number 2 when 2 items are passed in. And then what happens is this return value right here on this doInBackground is the value that's passed in for us automatically to onPostExecute. So this result under our scenario is going to have the value 2. And likewise, this method, if we look at it, there's nothing going on there. So we can come in here to clean this up and just take out that super call because no work's happening there and it's really not necessary. And maybe all we'll do for this is just tag on a message /n plus result plus space items processed. And now we're using the return value. So if we run this again now, I should probably shorten those up to a couple seconds a piece to speed up this demo. Processing task number 1, processing task number 2, done processing task 2, processing completed, 2 items processed. So now we can see how that return value comes into play. And again, that can be anything that you might want to return. And you can post that back to the activity that hosts this async task in the onPostExecute method, which receives that return value from the doInBackground method. So just think of this, that this return passes that argument into this onPostExecute method, and then your thread's safe to talk to your UI thread, and you can push it onto your UI thread from here. Now, one other point I want to make sure is crystal clear before we move on. You cannot talk to your UI thread from doInBackground. That's a separate thread of execution, and the UI thread of your activity is not thread safe. So, just to make that abundantly clear, I'm just going to take this started processing and move it here and try to talk to my UI thread right when I come into doInBackground rather than in pre-execute. Should have the same effect, right? Let's take a look. So we'll run that up again and start that and see it immediately blows up and our application is force closed. So keep in mind this doInBackground method, you're never going to reference your activity from doInBackground. Your place for that is on pre-execute, on progress update, and on post-execute, but not inside the doInBackground. Okay, so let's take that back out. And the next thing we now need to look at is orientation changes, configuration changes, but specifically an orientation change. When I'm on portrait and I go to landscape, or I'm on landscape and I go to portrait, let's look at what happens to our async task. And to do this, I'm going to get rid of my API 10 phone, and instead I'm going to spin myself up a API 16 phone that I call Jelly Bean Phone and start that up. The reason for that is the emulator has been improved in API 16, and it more accurately handles configuration changes than it does if you build a phone against API 10. So the emulator is going to give us a better experience at looking at these configuration changes by running this up to an API 16 emulator. Let's take a quick side trip before we look at configuration changes, and for this side trip I'll need to run this application several times. So to speed it up a little bit, I'm going to change this from 50 milliseconds to 25, so it'll take about half the time to run each time. And let's go ahead and run it up to my API 16 Jelly Bean phone. And then what I want to go do is go to the DDMS, and you'll see here is our process running right here. And we can click on that process and then say update the threads, and we can look at the threads of execution running within that process.